Welcome to this video series of the Python course. In the previous video, we got an overview of Python libraries, and in today's video, we will discuss about the NumPy library in Python. So, NumPy stands for Numerical Python and is a foundational library for numerical computations in Python. It provides support for multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. It facilitates arithmetic operations on arrays of different shapes, making array operations more flexible. NumPy offers a wide array of mathematical functions including trigonometric, statistical, and algebraic operations. So, importance of NumPy. Data handling. NumPy is essential for handling large datasets in data science due to its efficient storage and operations on large arrays. Foundation for other libraries. Many other libraries like Pandas, Matplotlib, and skitlearn are built on top of NumPy, making it a cornerstone of the Python data science ecosystem. So how can we create array using NumPy? Starting from a list. This line np.array 1, 2, 3 converts a Python list into a NumPy array. This array will have the same elements as the list and can be used for various numerical operations. Zeros array. np.zeros 2, 3. This line will create a 2 x 3 NumPy array filled with zeros. The argument 2, 3 here specifies that array should have 2 rows and 3 columns. Ones array. This line np.ones will create a 3 x 3 NumPy array filled with ones. The argument 3, 3 specifies that the array should have 3 rows and 3 columns. Arrange. The arrange function creates a NumPy array with values ranging from 0 to 9 here with a step size of 2. This results in an array containing the values 0, 2, 4, 6, 8. The step size can be changed by modifying the third argument, which is 2 in this case. Line space. np.linespace 0, 1, 5 will create an array of 5 values linearly spaced between 0 and 1. So the result in this case will be 0, 0.25, 0.5, 0.75 and 1. The three arguments here are start, the stop and num, where num is the number of values that we want in our array. Coming to array indexing and slicing. Indexing refers to the process of accessing individual elements or subsets of elements within an array or sequence. In context of NumPy arrays, we can access individual elements of an array using their position or index. In NumPy arrays, when you use a negative index, it counts backward from the end of the array. The last element of the array has an index of -1, the second last element has an index of -2, and so on. So here is an example of positive and negative indexing. AR0 will give us the output 1, which is the first index, whereas index 1 will be ARR1, which will give us output 2. For negative indexing, we have first given an example of ARR -1, which will give us the last element of the array, and -2 index will give us the second last element, which is 4 in this case. Slicing. Array slicing refers to the technique of extracting a subset or a portion of elements from an array. In NumPy arrays, the syntax is array name, and then we have 3 parameters. The first is start, second is end, and the last is the step parameter. The step size for slicing is optional and its default value is 1. Also, the end parameter index is exclusive, that is, it is not included itself in the slicing. So here is an example of array slicing. In the first example, we are extracting elements from index 1 to 3 of the variable for the variable ARR. And in the second example, we are extracting elements with a step of 2. So in the first case, the output will be 2, 3, 4, which will be the subset of values from index 1 to 3. And for the second case, the output will be 1, 3, 5 with a step parameter 2. Now we will see some array operations, starting from some element-wise operations. In this code, we've imported NumPy and created 2 arrays A and B, each containing 3 elements, as we can see over here. And we then performed various element-wise operations on these arrays, including addition, subtraction, multiplication, and division. So this is pretty basic element-wise operations we have performed over here. And these are the respective outputs that we will get for each element-wise operation. Now coming to mathematical operations. In this code demonstrates the use of various mathematical operations available in NumPy, such as sqrt, which will give us the square root of the elements in the array, log, which will give us the natural logarithm of the elements in the array, and similarly exponential, sine, cos, and tan, which are applied to us all the elements of the array. In the end, we will see some statistical operations. So np.mean here will give us the mean of the array, and then similarly we have different functions like median, std that will give us standard deviation, np.var giving us the variance, np.min, np.max that will give us the minimum and maximum value in the array, and np.sum which will give us the sum of all elements in the array. So now we will go to the Google Colab platform, where we will see some practical application of what we have learned today. So now we are at Google Colab, and let's see an example on how to create arrays using NumPy. So here are all the examples and different methods that we learned on how to create arrays using NumPy. And if we will execute this code, we can see that an array is created from a list, and then in the second case, a zero array is created of 2 cross 3, that is 2 rows and 3 columns. Similarly, a ones array is also created of 3 rows and 3 columns. And we can also see the use of range function and line space function over here. In the last two examples, we have changed the step parameter in np.arrange. In the first case, we have kept the step parameter as 1, and in the second case, we have kept the step parameter as 3. So we can see in both the cases the different outputs that we will get. Now coming to array indexing and slicing. First we will see what is an example on indexing. So in the first case we are taking the value at 0 index. In the second statement we are taking the value at first index. And then we also see two cases of negative indexing in which we are printing the value at index -1 and the value at index -2. So if we will execute this code, we can see that values 1, 2, 5 and 4 are printed, where 5 and 4 are the last and second last elements of the array. Now coming to slicing the array. In the first case, that is slice 1, we are extracting elements from index 1 to 3. In this case, we have not given any step parameter. But in the second case, we are extracting elements with a step of 2. If we will execute this code, we can see that both the arrays after slicing are printed. In the first case, we get a subset from index 1 to 3, and in the second case, we extract elements with a step of 2. Now coming to array operations, starting with element-wise operations. So these are very basic operations such as sum, subtraction, product, and division. So if we will execute this code, we can see that first we have created two arrays A and B, and then we have carried out element-wise operations on them. And this is the output that we will get. Now coming to mathematical function. If we execute this code, we can see that np.sqrt will give us the square root of each element in the array, and np.log will give us the natural logarithm of each element in the array. Similarly, we can use the sine, np.sine, np.cos, and np.tan function to get the sine, cosine, and tangent of elements in array. Finally, coming to statistical operations using NumPy. In these cases, we have used the NumPy to find the mean, median, standard deviation, variance, minimum value, maximum value, and sum of elements in the array. So if we'll execute this code, we can see that the mean, median, standard deviation, variance, minimum value, and maximum value, as well as the sum of elements in the array is printed. So this marks the end of this video, and that was all about NumPy library in Python.